Hi Deepak, am I audible? Hi Naidu, am I audible? One second. Am I audible? Okay. Okay. So today we are gonna see this sludge management. Mm, So good evening, everyone. I'm Shivashankari. I'm a PMRF scholar. I'm one of the TAs who is handling this live session for the subject wastewater treatment and recycling. And today is the eighth lecture. Like 8 weeks lecture. Like we are handling the doubt clarification session. Okay, so first I will explain few of the basic concepts and then we can move to the problem solving section. I have some 7 problems like to solve, and since it was requested in yesterday's class to show similar problems to the assignment problems, I have taken some very similar problems to assignment problems so that it will be easy for you guys to solve it and get your assignments done. So let's start the class now. Okay, so first of all, in the lecture, in this entire week lecture, what the professor had taught about is the sludge management. So it is basically the sludge management and treatment. Okay, so if we see a wastewater treatment plant, if we see the process of wastewater treatment, there will be majorly two types of sledges that is evolved from the process. Sledge generally refers to, can someone tell me what are the two major types of sludges that are generated in wastewater treatment plant? You are not audible, Deepak. You have to unmute yourself. Still, you're not audible. Okay. It is basically the primary and the secondary sludge. Primary sludge and the secondary sludge. So the primary sludge comes from the uh, primary settling tank, and the secondary sludge comes from the secondary settling tank. So, in the primary sludge, what it basically contains is settleable solids from the wastewater treatment plant. Because, like what we do in the treatment chain, first we keep the primary settling tank, and then comes this like secondary treatment, which can be ASP or trickling filter, something like that. And after that, the generated microbes in secondary treatment will be settled in secondary clarifier or secondary sedimentation tank, right? So, in primary settling tank, what you have is nothing but the settlable solids. In secondary settling tank, what you have is nothing but your secondary sludge or biomass that is generated via to the secondary treatment. Okay. So this is the like basics of your like what types of sludge is generated and everything. Now, um, so now in sludge, what is like present? Okay, this is what is like basically two types of sludge. Okay, but in sludge as a whole, what will be present? Okay, so sludge contains water and it contains solids. Okay, and in this solids also can be classified as fixed solids or volatile or organic solids. Okay. Okay. So apart from these, there are like few things we have to like discuss, like um that we can like see throughout in the problem itself. Okay. So these are the like basics you had to like know before solving the problems. So also you have one more thing. Volatile solids will be destroyed during digestion. Deepak, can you like keep in mute? Deepak, can you like mute
Yes, yes,
yourself?
sure.
Yeah. Okay.
Just waiting.
Yeah, 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 sure. Thank you. So will be destroyed during the digestion. So what will happen is like when you do aerobic digestion or anaerobic digestion, the microbes are gonna eat your organics, because organics will be the food in which they like survive, right? So in case of some aerobic digestion or anaerobic digestion, what will happen is your volatile solids will be destroyed, will be destroyed by the microbes. Microbes. So it can be aerobic or anaerobic. Okay, your fixed solids is gonna remain even after digestion. Okay, so I feel these are the like fundamentals you should like know before like solving the problem. Apart from that, I don't think anything else is required. So let's move to the problems. Let me share the screen. Is my screen visible? Okay, I think it should be visible. Okay, so what is given in the problem? In the problem, it is given that if one third of solid matter in a sludge containing 90% water is composed of fixed mineral solids with a specific gravity of 2.5, and two-thirds is composed with volatile solids with a specific gravity of 1. Find out the specific gravity of all solids. And the specific gravity of the sludge. Can someone tell me what is the formula to find the specific gravity of solids and then sludge? Naidu, can you tell me? Okay, I will solve this. So, problem number one, if you see, first let's write the given. Given what is given? 90% water. Okay, and then you have remaining 10% solids, and in that solids you have 2 by 3 solids as volatile, and then you have 1 by 3 solids as fixed. Okay, so this is the given content. Okay, so then what you have to find? To find, first you will need to find out the specific gravity of total solids. Second, you have to find the specific gravity of sludge. Okay, so the solution comes like specific gravity of solids 1 divided by specific gravity of solids equal to 1 by 3 divided by specific gravity of your fixed solids plus 2 by 3 times your specific gravity of volatile solids. Okay, so which is equal to 1 by 3 into fixed solid specific gravity is nothing but this given in the problem is 2.5 plus 2 by 3 divided by 1 is equal to 1 by specific gravity of total solids. So, Naidu, can you solve and tell me the answer for this? What is the specific gravity of solids from this equation? Naidu, can you solve and tell me? Okay, so
Ma'am, 1.02.
1.02. 1 minute, let me check the answer. By 3 divided by 2.5 plus 2 divided by 3. Invert 1.25. Let's check the answer. Yes, it's 1.25. So specific gravity of solids equal to 1.25. Now can you do the second subdivision similarly? This is for the first subdivision. For the second subdivision, we have to find the specific gravity of the sludge. Okay. So 1 by specific gravity of sludge equal to a percentage of water, I mean fraction of water divided by what is the specific gravity of water plus this is fraction. I will write it clearly. Then fraction of solids divided by specific gravity of solids, which we have found in the previous subdivision. Okay, so 1 by specific gravity of sludge equal to what is given in the question. 90% is water, so 0.9 divided by specific gravity of water is 1 plus fraction of solids is 0.1 divided by the specific gravity of solids we have found as 1.25. Can you solve and tell me for the sludge, specific gravity of sludge? I do.
Ma'am, 1.02.
1 second. Yeah, I'm also getting the same answer, 1.02. It's equal to 1.02. Okay, so that's all with this problem. Did you understand this problem, Naidu?
Yes, ma'am, I can understand.
Okay. So now we will go to the
Ma'am,
second. Yeah.
ma'am, something else. Ma'am, between the class, something you're going to ask about something about
Yeah.
due to due to technical issue, I couldn't catch that.
Okay. Due to technical issue.
I couldn't get your voice, ma'am. That's why I can't answer that question. Something you're
Oh,
going to ask
okay,
is
okay, okay, okay. No problem, no problem, no problem. That's okay. Okay. Thank you. So, yeah, we have solved this problem. Okay. So now let's move to the second problem. So, problem number two is, and this is similar to your assignment problem. Since yesterday Dinesh was asking some problem similar to assignment problem, I have like just changed the numericals in your assignment problem, so it will be easy for you to like solve, apply it for your assignment problem with the values that are given in the assignment. But like technically the process will be the same, but you have to like apply it and then submit it in the assignment so that it is easy for you people. Okay, so I have taken this problem. So in this, what is given is nothing but Q equal to 15 mld. Okay, and then you have inlet BOD 300 mg per liter. Okay, and then you have outlet BOD equal to 40 mg per liter. Okay, so mass of BOD removed during the process equal to 300 minus 40 into 15 kg per day. Okay, it's nothing but Q into concentration. Q into concentration is nothing but mass. Okay, so it is going to be 260 into 15. So it is, 1 second, let me calculate.
1500. 1500.
1500. How 1500? 260 into 15. Oh, you're telling the mass of BO, I mean like mass of sludge generated. Okay, so this is like 3900 I'm getting. 3900 kg.
Yes, ma'am, you are correct.
Yeah, 3900 kg. Okay, so from this we have to find mass of sludge generated, sludge solids equal to 3900. Okay, this is your like BOD removed into 35 divided by 100, because for removing 100 kg of BOD you get such solid of 35 kgs. So for removing 35900 like 35900 kg of BOD, we have to like multiply into 35 by 100. Okay, so which is equal to this will cancel. So 35 into 39. 35 into 39 is equal to 1365 kg. okay, per day. So that is the answer for first subdivision. Okay, so this is for the first subdivision. Okay, the second subdivision, what you have to find the volume of wet sludge. Okay, so volume of wet sludge generated in meter cube per day. Okay, so the formula for volume of sludge generated is nothing but mass of sludge divided by density of water into specific gravity of solids into percentage of solids. Sorry, into specific gravity of sludge. Just nothing but mass of sludge generated is 1635 divided by density of water is 1 into sludge. Specific gravity of sludge is nothing but your specific gravity of sludges. Here in the question it is given as the question what it is given, it is nothing but 1.1 into 3%. Okay, so if we calculate, it is going to be 1365 divided by 1.1 divided by 3, which is nothing but 413.63 meter cube per day. Okay, so this is the answer for second subdivision. For the third subdivision, we have if sludge is thickened to increase the solid content by 9%, weight is to weight, the weight of the sludge produced after thickening is in kgs. Okay, just a minute. I will just have little bit of water. 1 minute. I will just like have water and then we can continue. Okay, I didn't realize I was in mute. Just now I realized it. Okay, the third subdivision is basically what you have to find is the sludge produced is going to be thickened. Okay, so the solids contents is gonna increase to 9 percentage in weight is to weight ratio. What is the weight of the sludge after the thickening process?
Ma'am, I think your screen is not visible.
Oh, okay. Okay, so initially this much sludge is generated, and in this sludge, how much is the percentage of solids it is given in the question? Mm, in the question it is given as this contains 3% solids and 97% water. Okay, so the solids weight is gonna remain the same, only the percentage is gonna change, because we are going to do the uh, um, thickening process. Okay, in thickening process the water will be reduced so that the solids content is increased. Okay, but the weight of the solids is gonna remain the same. In first case, the weight of the solid, the in first case the weight of the solid is gonna be 3%, and in the second case, that is after thickening, the weight of the solids is gonna be 9%. But actually quantitatively the weight of solids is the same. It's just only we are changing the percentage of like water into it. After the thickening process, the water is gonna reduce in the thickened sludge. Okay, so it's basically if we take 1365 kg per day into 3% weight, so solids content in the sludge before thickening equal to 1365 into 3 by 100. Okay, so if we solve, we will get mm, 1365 into 3 divided by 100. We will get 40.95 kgs per day. Okay, so this is the weight of the solids. Okay, now after thickening also the weight of the solids is gonna remain the same. Okay, but this will be 9%. Okay, so after thickening also the weight of solids equal to constant equal to 40.95 kg per day, which is equal to 9% the weight of sludge, weight of thickened sludge. implies 40.95 is equal to 9 by 100 into weight of thickened sludge. Implies weight of thickened sludge equal to 40.95 into 100 divided by 9. So if we solve, we would get 4 into 100 divided by 9, 455 kg per day. Okay, so the answer for all three subdivisions are like first, mass of sludge solids generated equal to 1365 kg per day. Then the volume of sludge generated will be calculated and it is 413.63 meter cube per day. And finally, we have our weight of thickened sludge. So we have it as 455 kg per day. Okay, so with this problem is done. So now let's move to the next problem. Problem number 3. This is very similar to the assignment problem, but I have like just changed the numericals so that like you can like apply it, like apply the process for your assignment problem so that it will be easy for you. So in this, as in the question, what is given us? Let's write the given first of all. In the question, what is given is you have a sludge digester receiving mass of sludge received is nothing but equal to 15,000 kg per day. Okay, but the thickened sludge having total solids of 55% and 65% sludge solids are organic. Okay, so this is the mass of the total sludge. Okay, and in this sludge we have water and then solids, and in solids also we have inorganic or fixed, and then we have the organic percentage or the volatile. Okay, so it is given as having 5.5 total solids. So if this is 5.5, this is gonna be 94.5. Okay, and in this also they have given 65% of sludge solids is organic. So if this is 65, this is gonna be 35. Okay, so now the digester converts 70% of the organics in the sludge to a smaller liquid or gaseous end products. Assuming no reduction in the inorganic fraction of the solids during digestion, the amount of total solids in the sludge after digestion would be. Okay, so it's basically we have to find what is the percentage of organic solids that is remained without destruction, plus obviously the fixed solids will be like non-destructed in the process. So total value of inorganic solids and remaining fraction of organic solids. will give total solids after the digestion. Okay, so that is for first question. It's basically so 1500 into 5.5 divided by 100 will give the solids. Okay, and in this solids we have to account for 35% as such. So 0.35 plus 1 minus 0.7 into 0.65. Okay, this is for inorganic solids. Okay, inorganic solids will not be destroyed. Apart from that, your organic fraction undestroyed, not destroyed, because 70% of the organic molecules are destroyed. So remaining 30%, that is 1 minus 0.7 will give us 30%, right? Will be organics that are not destroyed. Okay, so if you solve this, you will get 1500 15,000 into 5.5 divided by 100 into, let's solve this.
I'm 4.96.
1 second. So it is 0.35 plus 0.3 into 2. Yes, it is 449.625. So it's basically option B, right? 450, approximately 450 kg per day. Okay, this is all about your first subdivision. For second subdivision, we have to find volatile solids to total solids ratio after digestion. So second subdivision, after digestion, ratio of volatiles to total solids ratio. Okay, so in the previous subdivision, we have found our like this is the ultimate thing, and in this you have to like find what is the volatile solids to total solids ratio. Okay, so in this uh, I mean remaining after digestion. Okay, so after digestion you will have 30% of your solids remaining. uh, so I mean volatile solids remaining. So this 1500, I mean 15,000 into 5.5 divided by 100 into um, 0.3 into 0.65. Okay, if you solve, you will get okay into total solids after digestion will be 5.5 into 100. After digestion, we will have. Oh, that is the thing we have found out in the earlier subdivision. Yeah, because that will be the amount of total solids in the sludge after digestion. Okay, so we can just rub this and write the value, exact value. It's nothing but 450 kg per day. Okay, and this is ratio of volatiles to total solids ratio after digestion. 1 second. So the answer is okay. So this is the answer.
Ma'am, could you, hello ma'am,
Yeah, tell me, Dinesh.
ma'am, could you please explain this, this second part, 15,000 into 5.5% is this solid, this one, and why second part I am asking. This is this
Okay,
uh,
okay, okay, okay,
30% of 65%. How you have made this formula and above that also. Can you
okay, okay,
please?
okay, okay. See here, in the question, it is given that you have this much solids getting generated, okay, and in that initially 94.5% is water, and then you have 5.5% as solids, and in solids you have 35% fixed solids and 65% volatile solids, okay.
That's okay, ma'am.
And in volatile solids also, one second, in volatile solids also, you have 70% of the volatiles getting destroyed. Okay.
Yes, ma'am.
So means remaining 30% volatiles remains after digestion.
Ma'am, volatile solid is are MLSS, no? Same similar thing. These are the
Yes.
bacteria.
Yes. Volatile solids are like organic solids. So it will be consumed by the microbes in the digestion process.
Right, ma'am.
Okay. So
Right.
70% is destroyed in that in that process, and 30% of the volatiles will remain in the after digestion also. Okay. So
In the
now,
sludge. In the
yeah,
sludge, no, ma'am?
uh,
In the sludge, it will remain 30% of this volatile solids.
yeah,
Please.
because 70% is destroyed, so remaining will be 30%, right? So it will I mean, it is given in the question. Okay, this is very similar to your assignment question, so like listen carefully. Okay, so it is very similar, not the same question but similar question. Okay, so logic
Yes,
is
ma'am.
this: first you have been given some sludge, and then in that sludge, what is the percentage of water and what is the percentage of solids it is given, and in solids also, what is the percentage of fixed solids and what is the percentage of volatile solids it is given, and then you have been given with how much percentage of volatile solids will be destroyed. Okay, so that is also given. Okay, so now they are assuming.
The volatile solids to total solid ratio it is asking. So uh, total solids are what? Total solids are 5.5%
Yes,
of
5.5%.
15,000. Means 15,000 into 5.5% is the total solids, out of which 65% of the sludge solids are organic. Okay, organic sludge will only convert into the this one gas and these are the volatile solid actually, no?
Yes,
65% of the sludge means uh, first thing is 15,000 into 5.5%, whatever is the value. Out of that X, 65% of the sludge are organic, and organic sludge is only converted to the gas or something,
yeah, and in that also certain percentage is only converted to gas, that is 70%.
and 30% remains as the residual solids.
Yeah,
Right.
okay,
Right, ma'am. Please,
okay,
now could you please explain the first this part you have written? Now explain your basics. First part, no, ma'am. First part also this formula you have written. 15,000 to 15.5. First formula is they are asking for the amount of solids in the sludge after digestion.
yeah. So
Amount of solid.
in the
Yes.
digestion process, see, total solids mass, 15,000, okay, and in that 5.5 percentage is your total solids, okay, and
Yes.
so I have written 5.5 divided by 100, and in
Right.
that your inorganics is not gonna get digested, right? So inorganics percentage is 0.35 in that. Okay, so I have written plus 0.35.
Right.
Also 30% of the organics is not destroyed. Okay, so
Mhm.
30% is nothing but 1 minus 0.7 into your organic fraction percentage is nothing but 0.65. Okay, so entire of inorganics will remain the same, and in organics your 70% will destroy, and then remaining 0.3% will be present in the sludge. Okay, so that's how I have like written it. It's basically just the logics, nothing huge. Okay, so if you try to solve this, you will get 450 kg per day.
Yes, ma'am.
Okay, so that's it. And the second subdivision also
Yes, ma'am.
determine the volatile solids to total solids ratio after the digestion case I have solved. Okay, so after the digestion, your totals, I mean like your volatile solids to total solids ratio you have to find. Okay, so after digestion, your total, oh, I'm sorry. Yeah. So after digestion, your total solids you have found as 450 kg per day in the previous subdivision itself. So, but after digestion, what is the percentage of volatile solids? Okay, so your total solids into your percentage of like I'm sorry, this is total mass of sludge into 5.5 by 100 is nothing but your percentage of your solids, and in that solids you have um, and in that solids you have 65% organics, out of which 30% is remaining.
Right, ma'am.
Okay, like without getting digested, without getting destroyed in the digestion process.
Right,
So
ma'am.
it's like 160.875. Okay,
Right,
so
ma'am.
if you see volatile solids by fixed solids after digestion process, it is 160.875 divided by 450. Okay, which is nothing but 0.373575. Okay,
Yes, ma'am.
similarly, if they ask for um, okay, volatile solids to total solids ratio before digestion. If you take volatiles to fixed solids. Oh, here it is total solids. I'm sorry. This is total solids. Equal to this. Probably they won't ask because this is directly given in the like question itself. You have um total solids percentages 5.5. In that you have 65% of volatile solids, right? So I think this is not the thing, like it's basically nothing but volatiles to total solids. Like before like digestion is nothing but 65%, which is actually given in the question. So like just for like showing, I have like shown. So one interesting thing is that your volatile solids by total solids ratio is getting reduced in the process because your volatile solids is consumed in the digestion process. So from 65% to it is getting reduced to 0.3575% after digestion. Okay, so like this can be an interesting observation. Okay, so that's all with this problem. Now let's move to the next problem. So problem number 3. Okay, A drying bed receives sludge with 4% solids. Given drying bed with 4% solids means 96% water is there. Okay, and the required final solids content is 20%. Volume of sludge. If the volume of sludge applied is given, volume sludge equal to 500 meter cube. Final volume of the sludge. Okay, so we have the formula V1 C1 equal to V2 C2, right? So in this, we know V1 as 500 meter cube, and in that concentration is nothing but 4%. Okay, we don't know V2. The final concentration is 20%. Okay, implies V2 is equal to 500 into 4 by 100 divided by 20 by 100. Oh, which is equal to 100 meter cube. Okay, this is a very simple problem. It's pretty easy. So now let's move to problem number 4. So the answer is 100 meter cube, option A. Okay, so the next question is, a sludge digester is receiving Q equal to, mass of the sludge received is equal to given kg per day. Okay, but you have 6% solids content. Means water content equal to 94%. Okay, the digester converts 75%. Okay, so apart from this, you have one more thing. 60% of the solids is organic. In this, 60% volatiles, and then you have 40% fixed solids. Okay, so the digester converts 75% of the organic solids. In this, 75% is destroyed in digestion. Means what? Remaining 25% remains after digestion. Okay, that is the meaning. Assuming no change in inorganic solids, the total solids in the sludge after the digestion would be. Okay, so now we have to find total solids in the sludge after digestion. Okay, so to find total solids after digestion. Okay, so we have a solution 18,000 into your solids content. It's very similar to the previous one. Okay, so in that you have 40% of the fixed solids will remain as such, and in that, in 60% of the volatiles, 25% will remain undestroyed. Okay, so this is the and this is the fraction of volatiles not destroyed equal to so the value will be equal to 5. Is Naidu tell me
594.
594?
594.
Okay, okay, okay. Let me just check 1 minute. Yeah, I'm also getting 594 kgs per day. Okay, so this problem is done. 594. Okay, that option is not given, but that is the correct answer. Like maybe I made some mistake in typing. I'm sorry. Okay, so for the next problem, it is
Ma'am, one question is there in assignment also. Somehow, somewhere, the question, this option is not matching. So, how to address this? I was
no, in assignment I solved and saw the option was matching. I think you should recheck your calculation.
okay that we were discussing, no?
Yeah, yeah, because that is different numericals. I solved the assignment problems and I changed some numericals over here. So I solved and I checked. I was getting correct answers. So I think you should recheck your calculation.
No, ma'am, that is okay. This is this is your self-made question. That's what you are saying, no?
No, the assignment problem, I have solved it and I have got an option.
Okay,
Okay, I have solved the assignment problem. The
okay.
same assignment problem I solved and I was getting options.
That is okay, ma'am. Ma'am, I am asking another thing. In the last assignment, I had already discussed, with you that, I'm not getting the options out of the four. So how to address this with the forum? So I'm not finding it. Naidu, if you have any information about this, how to ask this, suppose we have the time to submit the assignment and how to address this. That's what I'm asking.
Okay, you are asking how to ask in the forum.
Yes, yes, that's what I'm asking. Please,
Okay.
if you can
Mm,
guide us, that will be really valuable.
mm,
I
wait,
could
let
not
me
find
check.
this actually, no?
Wait. Let me check. I'm not sure how should we do it. Let me just check. Is my screen visible?
Yes, it is visible, ma'am.
Okay. See here. Um, just click on new conversation. Okay. See here. In the Q&A, you just click on Q&A. You will be redirected to the Google discussion forum where you can discuss your queries in the course faculty, um, as well the other students of this course will be there. Okay, click
Right.
on continue. Okay,
Right.
and then when you click on continue, you will have this. See here, I have a question. What is happening in the video? This, dear ma'am or sir, can you help me enroll this course? Like you can just ask, just start conversation, and then like just post it, I guess.
Okay, ma'am. And we'll post it in a here. Here is the only. This is the only link where it will be coming back as answer. I
Yep,
think,
yep. I think yes.
or it will be in my mail ID. I don't know. Anyway,
No, I don't think you will get a mail
because here,
ID.
see you here on different mail IDs are reflected. So that's I don't know how they have done it.
I'm not sure how that works,
See,
Dinesh. Like
there
I'm not sure.
from
You
and
can
to. Okay,
you can just
I'll try, ma'am. Yes,
yeah,
yes.
you can just type over here and like check like with the assignment like this and that. See, if the assignment answers are wrong, definitely they are gonna give you the grace marks. Okay. If it
That's
is wrong, definitely they will give the grace marks. If not, anyway, you will have the solutions, all the solutions, so you can look at it.
right. Thanks a lot, ma'am, for this guidance. Thank you.
That's
Please,
okay, no
please go ahead.
problem.
Mm.
Okay, so the next problem is problem number 5.
So
So
can I take the screenshot of the last solution because I was I'm not writing right now. I'm just understanding and taking the screenshot. This answer also. Just scroll down. I'll take the screenshot.
okay, answers I'm writing down in my notepad. I will just compile it as a PDF and then post it.
That's okay then. Please go ahead, ma'am.
Okay, or else I'm just keeping my iPad. You can just take a screenshot as of now.
Just a minute.
Yeah, sure. Sorry. I think it should be visible.
Yes, ma'am. It is visible.
Yeah.
Yes, ma'am. It's done. Please
Then?
go ahead. Yeah.
Okay, okay. Then I'll move to the next problem. Okay. Not this one, not this one. This one. Yes. Okay. So in this is also very similar to the like previous two problems we have discussed. So here it is like given. What is given? As digester digester receives 2500 kg per day of sludge. Okay, with 5% solids content. In this, 5% is solids and 95% is water. Okay, so in that specifically 72% is organic and the remaining 28% is inorganic or fixed. Okay, and in this 65% of the organic is converted to gas and liquid. So in this also specifically 65% is converted, destroyed, and 35% remains. Okay. So calculate the total solids after digestion. So total solids after digestion will be equal to 25,000 into your solids percentage is nothing but into 5 by 100 into your inorganic percentage into 0.28 plus your organic percentage 0.72, that is remaining undestroyed, that is 0.35. Okay, so if you solve, you will get the answer as 0.28 plus 0.72 into 0.35 into 5 divided by 100. Into 0.28 plus I'm getting the answer as 665. Answer is 665 only. These options are wrong. It's my typo, like mistake. I'm sorry about that. But yeah, the answer is 665 kg per day only. Okay, so this problem is also very similar to the like previous two problems. So what we are going to do is, this is problem number.
Ma'am, could you visible your iPad? I'll take the screenshot, please.
Okay, okay,
This is,
okay, sure, sure.
Ma'am, I get, I think, 434.5 per kg per.
For this answer.
Yeah, right. 437.5. Once you check in the options.
Okay, okay, okay. Let me just do the calculation. 10,000 into 8 divided by 100 into 800 into 0.8 into 0.32. I'm getting 364.
ma'am,
Um,
I'm also getting 665. I think your cost answer is right.
okay, that is okay. Yeah. For the next problem,
Ma'am, could you please explain this one? This bracket 25,000 of 5% of 25,000 is this one. Total
is
solid after digestion
this
into that
fif-
0.28 into this. This can you explain this, it again, please?
Okay. So, in this, you have your fixed solids is going to like remain after the digestion also. It's not going to change. Okay. And your volatile solids, in volatile solids, 65% is getting destroyed. That is what is like given in the question. Okay. So volatile percentage,
75% of 35 you written, but no. Okay,
see,
because
it's a
65 is
previous
organic and
question, Dinesh. It's the
yes.
previous question. That is the next question. You're asking the solution to be explained, right? That was for the previous question. I have changed the slide now.
Okay, please. Right. Then go ahead, ma'am, please. Sorry.
It's okay. So, if you see here, this is like total solids that is generated is this one. Okay. In the total solids, we have the fixed part and we have the volatile part that is undestroyed. Undestroyed.
Yes, ma'am. Got your point, ma'am. Because destroyed is 65% and another 35 is undestroyed. And
Yes.
72% of the solid are inorganic. And 7
Organic, organic.
are organic, yes, ma'am. So
Okay.
you have calculated 25 per 1000 kg per day into 5% into 28% are now inorganic, na?
Yeah,
Fixed.
inorganic
Fixed.
plus your
Plus
organic fraction that is undestroyed.
0.72 of 0.35.
35 because 65 is destroyed.
Right, ma'am. Please go ahead.
Okay, it is very similar to the previous problem. If you see, here also it is the uh, this is the total solids. In total solids, fraction of fixed solids I have given it as such, and the fraction of volatile solids that is not destroyed is nothing but your volatile solids percentage into the percentage of volatile solids like that is not destroyed in the process of digestion. Okay, so this is zero point 0.6 into 0.25. Very similar way in the like starting problem also I would have like done the same thing. See here where this,
Right, ma'am. I think that will be the similar problems will get us an idea of whatever the understanding is. No,
yes,
I think
yes,
that's good.
yes, yes,
Good.
it's the
When you will be
very like,
uploading this
same
lecture
logic.
tomorrow,
Huh? What?
this lecture when you will be uploading
Now
tomorrow.
I will upload. Now I will upload, but I'm
Uh,
not sure like when it will get like what to tell. The uploading will be finished. I will just upload tomorrow morning. You will be able to see it for sure. Okay. I will
that,
upload it now only.
that's okay, ma'am. That's good.
Okay.
Thank you. Please
No
go ahead, ma'am.
worries. Okay. So I have like taken very similar problems so that like it will be easy for your practice also because this problem is given in the assignment. Exactly similar problem is given in the assignment so that it will be easy for you to solve the assignment also. Okay. So now we have one more similar problem, the next problem. Okay. Here also, this is problem number 6. Okay. So you have digester receives equal to 10,000 kg per day. Okay, and in that 8% is solids and then 92% is water. Okay, so in solids also you have 68% organic and 32% fixed or inorganic. Okay. If the digester reduces 80% of the organic solids. So which means, oh, sorry, is destroyed, and your 20% remains after digestion. Okay, so the total solids after digestion we have to find. Is nothing but your 10,000 into your 8% solids, and in your 8% solids you're gonna have 0.32% fixed solids plus 0.68% organic solids, in which 20% is remaining fixed part, and this is volatiles that are not destroyed, which is equal to 10,000 into 8 divided by 100 into 800 into 0.32 plus 0.68 into 0.2, which is equal to 0.456, total equal to into 800 equal to 364.8 kg per day. Okay, so that's it. So yeah, so now I think I have one more problem. So yeah,
Ma'am, can you repeat again once? I
yeah,
couldn't
yeah, sure,
understand.
sure. This problem, right? Previous problem, right?
Yes, ma'am. I also want to take
Yes, ma'am.
screen.
Okay. So
Answer. Ma'am, pad also.
yeah. So this is like very similar to your like the very previous like three problems we have solved in this manner itself. Okay. So the digester is going to receive. So the digester is going to receive some sludge. Okay. So this is the total like sludge received by the digester. This is the sludge. And in this sludge, you have solids that are 8% given. Okay. So if solids are 8% in the sludge, then the water content in the sludge will be 92%. Okay. And in solids also, you have organics that are 68%. Okay, and then you have inorganic that are 32%. Okay, in the organic part, 80% is destroyed and 20% is remained, okay, after the digestion. So the total solids after the digestion will be equal to, first, your sludge mass that is received into 8 by 100. This will give the total solids that is received. Okay. In the total solids that is received, your fixed part will not be destroyed. Okay, as such, because this is basically a digestion process by microbes. So the microbes are gonna eat your solids. That is, microbes can eat only the organic solids. It cannot like eat the inorganic solids. So it's going to remain as such. That is nothing but 0.32. Okay, plus this 0.68 is your volatiles that are not eaten by the microbes. Okay, 0.68 into 0.2, because 80% of the organic solids are like eaten up by the microbes, or like used in like destroyed in the digestion process. Okay, so that's how that comes. This is the same formula I have applied in the past 3 to 4 problems. If you see here in the previous problem also, same sort of question. Digester receives this much kg of sludge, and then in that 5% is solids, 95% is water, and in the solids also you have organic percentage, you have inorganic percentage, and in organic percentage what is destroyed and what is remained. Okay, so your total solids into your fixed part that is not gonna be destroyed, plus your volatiles part which is not destroyed, so 0.72 into 0.35. So it is the very same thing I have like followed in 3 4 problems, if you see. And even in the problem previous problem also, same pattern. 1008 18,100 is like received total sludge. This will give the fraction of solids, total solids. In that fraction of total solids, what is undestroyed is your fixed solids that is undestroyed, and like the remaining part of volatiles that is undestroyed. So the volatiles part is 0.6 into your 0.35, which is undestroyed. Okay, so if you see the,
Yes, ma'am. These are similar, and the purpose of our calculation is to calculate the remaining solids. That is the reason you have multiplied the total solids, that is total flow of sludge, into the total solids
yes,
into the remained one, which are not digested by the
yes,
this MLSS or biomass.
yes, exactly, exactly.
So 32% is the remained one, and another one is organic part, that is remained one is added, and that is multiplied by that. So that's how we get the number. I think
Yes,
that's the
yes,
sum,
yes, it is the same logic.
right, ma'am?
Okay, if you see all the problems, this is the same logic, and this is asked in the assignment problem also. So there also we have to apply the same logic.
Right, ma'am. Great.
Okay, so that's all with this problem. So last problem I have, but this is not that important because like this is not given in the assignment problem. It's just for your like understanding. Okay, so I have like taken a problem. You can just like see and try to understand the logic. That should be okay. Okay, so you have a wastewater treatment plant with total solids. Okay, so this is problem number 7. You have wastewater treatment plant that produces solids produced in the treatment plant equal to 1200 kg per day. Okay, of total solids in its sludge. Okay, the sludge is mechanically dewatered. Okay, to 6% of solids before applied to the drain beds. Okay, so sludge is dewatered. Before applied to the drain beds. Okay, so first you have a wastewater treatment plant. Okay, and in that some sludge is produced. Okay, and this sludge is sent, sludge produced is dewatered. Here dewatering happens to 6% weight is to weight. Okay, and then it is applied to the drain beds. Here drain beds are there. So sludge is produced in the wastewater treatment plant, then it is dewatered and then applied to the drain beds. Okay, so the sludge um, like um, uh, produces 1200 kg of total solids in its sludge. Okay, so solids in the sludge, solids in the treated in the produced sludge of this is, oh, okay, so this is 1200 kgs per day. Okay, oh, so this is how like it is given in the problem as of now. Then the target final solids content in the dried cake is 35%. Okay, here it should be 35% of the weight is to weight ratio. Okay, so 35% of weight is to weight ratio solids. The specific gravity, that is the bulk density of the wet sludge is 1.1. Okay, uh, or 1100 kg per meter cube. Sludge is applied continuously and each batch is left on for 10 days of drying cycle. Okay, so um, wet sludge specific gravity is given as wet sludge specific gravity is given as 1.1. Okay, and then it is a sludge drying cycle is equal to for 10 days. Okay, the maximum workable depth of wet sludge is 0.25 meters. So depth equal to 0.25 meters. Depth of sludge. Okay, calculate the volume of dry sludge applied per day. First one you have to find volume of wet sludge applied per day. Then you have to calculate the mass of dried cake produced per day. Third one is you have to calculate the area of bed to handle 10-day cycle. Last one is you have to calculate the mass of water removed per day. Okay, so let's go to the solution. So, like, mm, yes, whatever we have written as like given, they have like written. But one thing is, initial solids fraction is 6 percentage. That is here. That is here it is C1 is equal to 6 percentage. When it goes to here, C2 is equal to 35 percentage. Okay, so this is C1 and this is C2. Okay, and then rain 10 days, everything. Okay, so volume of wet sludge is equal to um, nothing but your uh, first, for finding the volume of wet sludge, we need to know what is the mass of the wet sludge, right? So to know what is the mass of the wet sludge, to find volume, we know density equal to mass by volume, right? Density equal to mass by volume. So to find volume, you need mass and density of wet sludge. Hana. So density of wet sludge is given in the question as 1100 kg per meter cube. You don't know what is the mass of wet sludge applied, okay? But you know what is the solids mass. Solids mass, and what is the mass of a percentage of solids in the total sludge initially when applied. Okay, solids mass is equal to 1200 kg per day. Okay, which is nothing but 6% initially, which is equal to 6% of your weight of wet sludge. Implies weight of wet sludge per day equal to 1200 into 100 divided by 6. Okay, so this will become 200, which is nothing but 20,000 kg per day. Okay, so this is the weight. You know what is the density. Okay, so volume of wet sludge is equal to mass of wet sludge, which is nothing but 20,000 divided by your density 1100. This is in kg per meter cube. This is in kg per day. Kg getting cancelled is equal to this is cancelled. So 200 by 1100. So the answer will be 18.18 meter cube per day. Okay, so that is the answer. That is what we have also got. Okay, so next subdivision, what you have to find is mass of dried cake produced per day. Okay, so option B, you have mass of dried cake produced per day. Okay, so um your final uh, dried solid will have 35%, right? 35% of your final solids fraction. Hana. So your dried mass cake will be equal to, dried mass produced is equal to 1200 divided by 0.35, which is equal to, if we calculate, we will get as 1200 divided by 0.35, 3428 kg per day. Okay, so the next subdivision what we have to find is area to handle 10-day cycle. Okay, so area to handle 10 days cycle. You know, in one day 1818 volume is generated. Okay, volume of sludge generated in a day. Okay, so for 10 days how much will be generated? 10 days means into 10. Okay, so that will be the meter cube of your sludge produced. Okay, but in the question it is given as the depth of the sludge that you can like apply is 0.25 meters. So I'm gonna divide by 0.25. So totally it will be in meter cube divided by 0.25. This is in meters. So if you calculate, you will get the area. It's nothing but 727.2 meter square. Okay. So the last subdivision will be what is asked in the last subdivision. What is the answer they have given? Yeah, we are also getting the same answer, 727.2. Then in the last subdivision, what is asked is mass of water removed per day. So your mass of wet sludge produced in a day is given already. Okay, so this is the wet sludge produced in a day. I mean, like we have calculated earlier. It is nothing but 20,000 kg per day. Okay, but your mass of final sludge is going to be, that is the dried cake is going to be 3428. So which is equal to 16571 kg of water is removed in a day. So if we want it in like meter cube of water, so density equal to mass by volume. So volume equal to mass by density, which is nothing but 16571 divided by 1000, which is equal to 16.57 meter cube per day. Okay, so that's it. So yeah, that's all for today's class. So yeah, we will like meet in the next session, and I will like upload both the solution PDF as well as the question PDF. I mean like question PPT as well as the lecture by tonight, so that like you can be like you can use it tomorrow to study if you want. Okay. Thank you everyone for attending the session. Thank you. Do you have any doubt?
No, ma'am.
Okay. Okay then. Thank you. Thank you everyone.
Thank you, ma'am. Ma'am, how was your health?
Yeah, yeah, it's good. It's good. Thank you for asking, Naidu. Thank you. I'm good. Yeah. Bye bye.